Hi guys, today we're doing area of sectors, which you've got to learn what that is, and we're actually also including the length, finding the length of an arc. So we have lots of work to do. It'll take some time, so let's get going. Okay, so do copy down these two I can statements. We're going to be able to find the area of a sector of a circle. We'll show you what that is, and the arc length of the circle, that actual distance. Now, for your vocabulary, please draw the picture and let's write a couple things out, and then you're going to have two main formulas that you'll need. So let's first kind of define a sector. Seeing it is easier than describing it. It's like a piece of pizza. So it's a section of the circle. So now that I've said that, it probably makes perfect sense. That shaded gray area is a sector, and we can find the area of that. And the area of any sector is going to be just that fraction, whatever piece of that pizza is, that it is of the entire circle. So it is a fraction of the area of the entire circle. I'm not going to even write out area there. Whoops, let's write entire circle though. Let's use a real basic picture. Not even this one. Well, it kind of could be that one that's drawn, but let's split one up that will really make sense to you. If I did a picture like that, most of you are going, I know exactly how much that is. That's a fourth of the circle. So that sector would be, the area of that sector, would be a fourth of the total area of the whole circle. So it's that easy. So what fraction would it be? You use that concept to come up with the formula. You work it out as a proportion. So this is what you'll need to copy down and memorize. You can put it on your cheat sheet. And here's the way it works. Let's get it written and then we'll talk about it. That's what you're going to use today. To find the area of a sector, so to find the area of a piece of the circle, then it is proportional. The sector piece is proportional to the whole area circle in the same way that however many degrees it is. Again, going back to this picture I drew, most of you are going, hey, that's a fourth of the circle. So that's 90 degrees of the 360 degrees in the circle. And you would put, if you were working a problem that had that picture, you'd be putting the 90 right there. So let's see how it works. Before we do that, let's also draw our arc length and write that formula. This is arc length. You know that already. That is an arc. We learned the first day of circles. And you can find that distance, that length, using the same concept as we use here for sectors. We're going to use S and try to make like a cursive or a curvy S, or otherwise it'll look like a 5. S over C, where C is the circumference, is the fraction, because think about it, that little blue section is a fraction of all the way around the circle and all the way around the circumference. So the fraction of S out of the entire circumference will match up with however many degrees out of 360 degrees that you're using. So let's go write some things beside of this. This will find you area of a sector. This formula or proportion will find you the length of an arc. Let's go use them. Okay, we will use one of those two formulas. The only other thing that could get messy, and it happens on our first couple of examples, we have to take care of this 2 pi thirds. That is in radians. We will actually leave our answer in radians or degrees. I'll show you how that works when we get to the end to our answer. All right, but let's figure out what we need to find here. We need to find the area of the sector, so we need to use this formula. Go ahead and copy it from your vocabulary section. We need the area of the whole circle, and we'll need however many degrees it is out of 360. So our first job, let's convert that 2 pi over 3 to degrees. We learned that in our last lesson. If we want to change that to degrees, we'll multiply it by the 180 over pi version so that we can wipe out pi's. We can even do 3 into 180 is 60, and that answer would be 120 degrees. So that's what we use for M. You could have left it in pi, but you probably really don't want to. All right, so pay attention to what we say. Therefore, why you need to listen to the videos also about how we fill in area of the circle here. All right, so let's set it up, and you'll see we're missing something else. We're looking for this area of the sector. We need to find the area of the circle. We'll go down here and do that in a minute. That's not hard. That's like 5th grade. And our M is 120 degrees, and we've already got 360. So we are ready to roll, almost. Now, let's go find the area of the circle. That is pi r squared. You've known that for a while. And let's fill in what we need there. That would be pi times the radius squared. The radius in this picture is 8. So that answer would be 64 pi. I'm going to do my work with the 64 pi still in there. You could change to a decimal right now. If you do that, please use the pi button. But I want to try to convince you that you can make it work quickly and with less math and less time on your calculator if you leave it in pi. So let's put that 64 pi in for the area of the circle. All right, let's cross multiply because we're trying to find area of the sector. So 360 times that area of the sector, I'm just going to put A with the little s down at the bottom, equals 120 times 64 pi. I'm going to do straight math this time, and then we'll talk about places where you can simplify and reduce to make your life easier. So 64 times 120 turns out to be this huge number, and the pi symbol is still there. If we're solving for A, we need to wipe out that 360. You'll catch on that the steps are the same every time. So the area of the sector now will be 7680 divided by 360. If it does divide evenly, that makes it real easy to leave it in pi. This one does, I believe. 67, and you can leave that pi symbol in your answer. You do need to add the correct units. This is area, and anything in area is square units. These were yards. So there is our final answer, 67 pi square yards. And if you did choose to use the pi button, you would have the decimal, which I did not work out because I'd rather leave them in pi. That's less math for me to do. Let's go to another one. Okay, example 2 asks for the same thing, area of the sector. So in this one, it's also given to us, the degree is given to us in 3 pi over 2. I'm going to just tell you what that is in degrees. We make that change like from our last video, it'll be 270. So that'll be our M. So let's set up our formula. Area of sector, area of whole circle, M over 360. We are looking for area of the sector, so the only thing we need to do before we really get rolling is come to the side and find the area of the whole circle. That is just the area formula. You've been doing that for years now. Pi r squared will be pi times 10 squared, 100 pi. Leaving it in pi makes your life easier. So let's go fill things in. Looking for the area of the sector. We know the area of the whole circle now. We know M. In degrees, that's the easier version, and 360. Let's talk about some easy simplifying, reducing you can do. Here's something you can definitely do. Most people are good with that. Lose those zeros. Now you don't want to do that to the 100 over there. But now you could just work with the 2736. If you like the bigger numbers, you've got a calculator, so it doesn't really matter. Let's do cross products. 360 times the area of the sector. You should, even after just 2 examples, realize that that happens every time. 27 times 100, 2700 pi, and we're solving for the AS, so we need to divide out the 360, and we'll have our answer. But let's see what happens. This time when you divide 2700 by 30, oh, excuse me, that's not 360, is it? That's supposed to be 36, because I lost my 0. So when you divide 2700 by 36, it does go evenly, but I still have to show you the ones where it doesn't. You should end up with 75 pi. This is in inches, so area would always be square units. 75 pi square inches. If you use the pi button, please don't type 3.14. Use the actual pi button on your calculator if you want to change it to the decimal answer. And that's what it would be. Let's move on to arc length. Arc length is almost the same setup, still uses that M over 360. Please check your your vocabulary notes, and we want to do S over the entire circumference. So just like in the previous problems, we had to go to the side and find the area of the whole circle first. Here we'll have to go to the side and find the circumference of the whole circle first. And please make sure your S looks curvy or something so it does not look like a 5. You've got to be able to read your own writing. Let's quickly take that 17 pi over 12. I won't even do the times pi over 180 over pi here. I'll just tell you it becomes 255 degrees. I think in your assignments we gave everything to you in degrees. All right, let's also find C, circumference, because we will need that. Circumference is this formula, pi times diameter, or 2 pi r. If you're given the radius, you might as well go with that. So let's go 2 times pi times the radius, 20 pi. That's what we need to use for circumference, because like just in the other ones, you prefer to leave that pi in there because you might get to cancel it out or just leave it sitting in your answer. Let's fill in this formula, solving for S. We don't know S, we do know C now, we do know M, and 360 is always there. Now, you could do some cross-canceling here, at least by 5s. Since I have a calculator and there's nothing that's really quick and obvious, I'm just going to do the cross products. 360s equals 20 times 255 with a pi on it. That's just like a variable. Now, when you divide this one, the 5100 divided by that 360, it does not go evenly. So you have some options here. You can use the pi button at any time to type in what pi is equal to. And if you do the math, you'll end up getting this as a decimal, and that is in yards. Nothing squared here because it's just a length. It's an arc length. And the other choice is you can leave it in pi and just reduce the fraction part. Example 4 is the same. Let's go ahead and write down the conversion of that 3 pi over 4 turned into degrees. That would be 135 degrees. You need to do that practice because you'll be tested on it, but today we're not going to take the time. So that angle measure right there is 135 degrees. We'll use that. We are finding arc length, so we're going to use this version of the formula. Straight out of your vocabulary. We're looking for S. We need to go to the side and find C, 2 pi r. And again, that's really like a 4th, 5th, 6th grade concept, finding the circumference. It'll be 2 times pi times the radius, which I've marked all over, but I believe it was 16. So the circumference is a 32 pi. That's what we fill in up here now. So S over 32 pi equals M, we've got that, over 360. Let's do cross multiplying. 360 times S equals 135 times 32. That's a big number with the pi symbol on it. That'd be the same as if there was an X in that spot. Divide by your 360 to solve for S. And you can leave pi, you wouldn't leave pi in your answer on this one because it would be a decimal. No, I think it comes out right. I'm not looking at my notes correctly. 4320 divided by 360 does end up being 12 pi. So when it divides evenly, it's easiest to leave it in pi. That's less math to do. You don't have to hit 12 times the pi button. But if you did, your answer would round to that. So the answer for the arc length is 12 pi, or 37.7, and we happen to be in miles here, so that, of course, is a huge circle. Let's look at some more things. Just when you thought we were done. I hope you're listening to the video. We are not done. In the previous lesson on radians, we had told you to skip example 3 and 4. We are going back to those now, so please flip back in your notebook to those 2 examples. I'm not even going to draw the pictures. I'll read them and get the information, but you do need to add this picture. At the top of your example 3, before you work out the problem, just draw a basic picture because there's one more formula version you need here. Let's just draw a sector in, and on that sector put a theta for the angle measure there, and let's put an R because those are radius lengths. And then also let's put an S out here because that is an arc length, and we just learned about that. This formula works every time. Let's write this down. Here is another given formula that will fit these problems and will always help you find missing things. when it's one of these three things missing. You could be given the angle, the arc length, or the radius. As long as you have two of those, you can find the third one. So that's what we're doing in these problems. So this is the example 3 from the previous lesson. I'm just going to read it real quick. You've got the picture. A circle has a radius of 4 units. And they ask us to find the radian measure of the angle, so that means find theta. If you know that the arc length is S, is 10.8 units. Now, your answer won't have pi in it or anything. It's simply going to be throwing them into these 3 spots and finding the missing number. So it will seem weird that your answer is like 7 radians, but that's just how you would answer these. All right, let's fill in spots. We don't know theta. We do know S, and we do know R. Simply pick up your calculator, do the division, you're done. Theta is 2.7 radians. And again, that seems weird because you don't know what radians are, but don't let that bother you. So super easy. Let's do one more. Look at example 4. Look at your picture. I'm not even going to bother drawing it, but I'll read it. The circle has a radius of 3.8 units. Find the length of the arc. So we're missing S. Sorry, my S got a little too curvy there. And it says the central angle measure is 2.1 radians. So 2.1 for theta. The formula, again, is like this. You just have to memorize it. Let's throw in what we have and find what we're missing. Let's put 2.1 in for theta. We don't know S, and we do know R. And you've done enough of these this year. Hopefully you're thinking what you need to do next. The simplest way to solve this would be throw a 1 under that, or just recognize that it was S divided by 3.8, so you need to multiply by 3.8 to get your answer. 1S equals whatever 2.1 times 3.8 is. And I believe the answer is 7.98. That is a length. They just said units, so I don't think we can call it inches or anything. And you're done. Now, please notice that we've only got a couple more videos left, so we're more than halfway through. You should have had lots of times in class that you could work and get caught up, but if you're not, let's get going on it. Have a great day.